Okay, we're going to look at convergent geometric series. So that's when the sum converges to a particular number. So I think we've seen this before, but if you look at 1 plus a half plus a quarter plus an eighth plus a 16th, we've sort of, I'm pretty sure, visualised what happens with this before. So if I've got a whole one and then I add on a half and then a quarter and then an eighth and then a 16th, then a 32th, then a 64th, and so on, you can see from there that that series is going to converge to 2. If we look at what happens when we put it into the formula for the sum of a geometric series, so A is 1, R is equal to a half, so we're timesing by a half to get to the next term. And so the sum of the first n terms is A, lots of 1 minus r to the n all over 1 minus r. So tidying that up a little bit, obviously that 1 isn't doing anything. So I end up with 1 minus a half to the power of n over a half. I could times the top and bottom of that by 2 and tidy it up. I'm going to leave it like that. As n approaches infinity, so this is an infinite series, then you should be quite happy with a half to the power n approaches 0. So a half times a half times a half times a half, you're going to approach 0 relatively quickly actually because it's exponential. And so this sum here will approach, so half to the power n is going towards 0, so this sum is going to 1 over a half, and 1 divided by a half is equal to 2. This is called the sum to infinity of this series, so you're letting n approach infinity, and the series converges to 2. So it converges to 2, and 2 is the sum to infinity. This pen is running out. So it's sum to infinity. Notation for that is S infinity rather than n of the series. So if I go back to the formula for the sum of the first n terms, so sum of the first n terms is a lots of 1 minus r to the n over 1 minus r. Then provided r is between minus 1 and 1, then as n approaches infinity, r to the power n will approach 0, and the series will converge to a over 1 minus r. So if minus 1 is less than r is less than 1, then as n approaches infinity, r to the power n approaches 0. So that's exactly like this half to the power n here, approaching 0. And s to the n approaches, so if this bit here goes to 0, you're just left with a over 1 minus r. And so the sum to infinity of a geometric series is equal to a over 1 minus r. So you need to know that, which the sum is definitely in the formula book. I think the sum to infinity is. I really need to print out the formula book and be very vague about it. Let's just put in this proviso. So provided minus 1 is less than r is less than 1. That's the same as the modulus of r is less than 1. So you could write it like that. And just note that if r is greater than or equal to 1, or r is less than or equal to minus 1, then the series will diverge. So the numbers will just get bigger and bigger and bigger, because when you do r to the n here, it's just going to get a bigger and bigger and bigger number. Unless r is 1, but in that case you're just going to be adding the same number on each time and it'll still diverge. So the series will diverge instead. So I think I'll stop that clip here, and then I'll go over a couple of examples just using that sum to infinity on the next one.